Koyama-san from NHK STRL. Koyama-san is a research engineer in the Advanced Transmission and System Research Division of NHK. And he's going to give us a presentation about the implementation of an 8K vision mixer that transports 8K images as multiple 2K SMPTE 20 to 10-20 flows. Of course, this is important towards the year 2020, I would assume, with the Olympics. Koyama-san, you have the floor. Thank you.
So, thank you, Mr. Hoffman, and thank you, everyone. My name is Tomofumi Koyama from NHK, Japan Broadcasting Corporation. My presentation title is Implementation of 8K Vision Mixer that transports 8K image as multiple 2K SMPTE ST 2110-20 flows. So a little bit long, but not, the content is very simple. In this presentation, I would like to explain the background of our activity, and I'd like to introduce our 8K transport method and POC. Okay, at first, I would like to talk about 8K Super Hivision. 8K Super Hivision has 60 times as many pixels as STTB and 22.2 multi-channel sound system. So it gives a sensation of realness, as if you were there. So, and we have already tested. We have already tested satellite broadcasting system, and the practical service is going to be launched in this December. So to start 8K broadcasting service, of course, we need to make 8K programs. So we are developing 8K studios, OB tracks, and editing systems. But it's not easy to deploy 8K systems because the data rate of 8K is very huge. So the 8K device needs a lot of connections and links. So this table shows how many links are required to transport 8K and 4K. As you know, we need only one HD SDI to 2K to transport 2K, but for 4K 60 Hz, we need 4 3G SDI links. But this multi-link system is not convenient because the device becomes heavy and large. So please think about OB tracks. The space and weight of devices that are loaded on the track are very limited. So we need a device, we need to make a device simple. So as you know, 12G SDI was standardized. This 12G SDI can transmit 4K streams with only single link. But how about 8K? 8K needs 4 12GB SDI, and we are developing full-featured 8K. It is 112 Hz and 20 bit depth and 444 sampling structure. The data rate of full-featured 8K is 143 gigabit per sec. Too high data rate, so we need another device. At the moment, the 8K the back panel of 8K device is like this, very, very complicated. So on the other hand, the IP networks, the bandwidth of IP networks is increasing rapidly. And now it is higher than SDI. So 25 gigabit Ethernet can transport 2 4K streams on one link. And 100 gigabit Ethernet can transport 2 8K streams. So we must use IP networks to deploy 8K production system. So now we are developing IP-based 8K production system, POC. It's the background of our activity. So next, we need to think about how to transport 8K video signal on the IP networks. In other words, we need a packet format. SMPTE ST 2110-20, which specifies packet format to transport uncompressed video over IP network, was published last December. It already supports 8K resolution. Actually, it supports up to 32K resolution, so it's sufficient. So at first, we thought we could use SMPTE 2110-20 to transport 8K. But if I send 8K and directly with SMPTE 21-20, the 8K stream is one single RTP flow. It means we need 100 gigabit Ethernet to transport 8K. But it's not convenient at the moment, because we have already a lot of 10 gigabit connection and 25 gigabit connections. So this cost is big problem for our management division. So we need another method to encourage to move to IP-based infrastructure, IP-based 8K infrastructure. So we make another method. It's very simple. This is the outline of our system. It's composed of 8K transmitter and 8K receiver, and there's a lot of 2K video processors. To transmit an 8K image with lower bandwidth connection, this transmitter divides 8K image into 16 2K subpictures. And each subpicture is sent as a ST21-20 flow. So this flow, the bandwidth of this flow is lower than 10 gigabit bit per second. So we can use 10 gigabit or 20 gigabit Ethernet connection to transmit 8K, to transmit 16 2K flows. And the 2K ST2110-20 flow is the same as the ordinary 2K flows. So we can process these flows on the conventional 2K video processors. And at last, the 8K RX receiver converts them into the original 8K image. So this architecture has, I think, this architecture has 3 advantages. So let me introduce them. So first advantage is 8K device can use multiple low bandwidth connections and transport 8K image connections to transport 8K image. So of course, it is no problem to use 100 gigabit Ethernet to transport 16 2K streams, because it is not a problem for IP networks to multiplex several streams on the same link. So we don't need change application when we upgrade infrastructure. It's very important. We don't need change application, so we can start to deploy networks and applications. And after, so when high-speed networks become affordable, we can change the network to 100 gigabit Ethernet. Second advantage is devices for 2K production can be used for 8K production. Our 2K subpicture has the same structure as ordinary 2K image, so we can use 2K video processor to process 8K image. So it means we can start with this small infrastructure for 2K production. And if you need 4K or 8K production system, you can expand the system you have already. And of course, it can use for 2K, for 4K, for 8K. So you don't need to have several systems for multiple resolution production. And third advantage is this method is suitable for virtualization. This is the JTNM roadmap. We are now here, elementary flows. So next step is management, like AMUA NMOS. And after these steps, JTNM think production system will be software-based and deployed on the cloud system. It means processing application as production system will be software-based, so running on CPU. Processing 8K image on CPU needs high CPU power, but our architecture divides 8K image into 2K images. So we need only a 2K processor. So it's very easy to implement in software. And of course, CPU will be improved. So in future, we can run multiple instances on one CPU. As in the case of network connection, we don't need to change the application when hardware is upgraded. So we can receive advantages by dividing 8K image into 2K images. But there is no disadvantages. Okay, and next, I'd like to talk about dividing method. Square division, SQD and 2SI are conventional method to divide an image into raw multiple images. We use 2SY-like dividing method. So 2SY is two sample interleave. So the sub-image or generated by 2SY is very like original image, like this. So we can monitor 8K video by only one sub-picture. And it can be displayed on 2K display. So we can use 2K monitor as part of 8K production system. And this figure shows pixel mapping. 42 to 10 bits depth is the same as the 2SY. But our dividing method is based on P group. P group is a minimal group of samples that align to an octet boundary. Octet boundary is very important for CPU. So converting process is easy. So in the case of 444, 10-bit depth, it's not 2SI. It might be called 4SI, and 420, 8SI. But it's easy to calculate on CPU, with CPU. And of course, IP network is very flexible. So 2SI for SDI need to add stuffing when 420 10-bit depth images splitted by 2SI method. But for IP networks, this stuffing is not needed. So it's more efficient. And one more advantage is it's good for error concealment. If packet loss occurs, the lost pixel is dispersed. So it is easy to conceal by adjacent pixels, like this. This is a diagram of our implementation. It has two 8K to 2K sub-picture converter. It sends 60 2K sub-picture flow, and there are 16 2K vision mixer, and the output is sent to the converter. So this system can switching to 8K videos. And additionally, we implemented 2K viewer. It can monitor 8K image. Only it can monitor 8K image by receiving only one 2K flow. So this picture is, we demonstrated our system in our laboratory's open house in May 2018. So this large display is 8K display. This shows our output of switcher. And this small display shows 2K sub-picture. You can see the sub-picture image is very similar, very like to original image. So, but this display is 2K. So it is very convenient. And this is a diagram of 8K to 2K converter. It captures 8K image and divide into 16 to get sub pictures and send to get 2110-20 flows. And these flows have same RTB timestamps. So 2K to 8K RX receiver can synchronize 16 flows and convert them into original 8K image. This feature is given by 2110 system. It's not our effort. So the 2110 system is very useful. And I'd like to show an example how software implementation is flexible. This left image is original 8K, cropped 8K images. And this one is a subpicture 1. So divide it into 2K image by 2SY method. So you can see many artifacts because it is generated by sampling method. It is OK to monitor 8K image, but I'd like to improve this image quality. So I added some smoothing feature to 2K viewer. The result is this vision. So I don't know how this image is good or bad, but this artifact might be improved, I think. So, but it's a just example. The important thing is software is very flexible, and we can test and add new feature for our broadcasting service. This quickness is very, very important, I think. Okay, at last, I'd like to watch the demo video. We demonstrated two devices. One is this 8K transmitter with mezzanine compression. It transmits 8K image via 1,000 kilometers length, and it shows it demonstrated remote production. Mezzanine compression doesn't make delay, so very, very quick. You can see the quick response, and this is our system. So I made a 8K vision mixer. Okay, conclusions. So we implemented IP-based 8K production system, POC. The system sends 8K as multiple 2K ST2110-20 flows. And this system has 3 advantages. We can use low bandwidth connection to transport 8K. We can use 2K production devices for 8K production. And it is easy to implement in software. And the transmission method does not become a disadvantage because 2110-10 provides a mechanism to synchronize. And IP network is good for multiplexing flows. So I think this method, I hope this method to encourage to move to IP-based production system and move from 2K to 8K. Okay, that's all. Thank you.
Very good paper. Here we go. Hel Kovalik.
Nice presentation, good engineering. 2 questions. One, when you divide the 8K image into 16 2K images, you're going to have aliasing for some video processing on the 2K. What are your limits on aliasing?
Aliasing. Actually, we don't think that use 2K images for production. It's our system divides 2K images for transmitting, only transmitting, or monitoring. So actually, I don't care any aliasing.
Okay, good, because you had a demo where you were showing some effects, and if you extended those effects, you would have aliasing. Second question is, how do you keep the 16 channels straight? Do you have an ID of some sort to be able to indicate if I swap 2 of the 16, you're going to get a different image? How do you keep them straight?
It's a good question. If we need to use this method globally, we need some standardized process. But actually, we manually configure which destination address is this number X subpicture, and so we mapped manually. Okay. Thank you.
Hi, Nigel Seth-Smith. I'm chair of SMPTE 32NF70 UHD SDI. I completely agree with the idea of using sub-images, which is why UHD SDI has used it for the last 3 or 4 years. But I'm very concerned that you're using a different dividing technique, that your 2SI is different for a number of reasons. The very first one being, of course, compatibility. The second one being, I think your aliasing is twice as bad, which is obviously, you say you don't care too much about aliasing, but you're bound to care somewhat about it. As I understand it, the only advantage you have is higher efficiency on 420. I always think of 420 as a subsampling technique used just for transmission to displays. In a highly compressed environment, in a full bandwidth environment such as this, where the signal is almost certainly going to undergo processing later on, are you really going to be using 420? It doesn't feel to me like the advantage of higher efficiency on 420 is worth having a difference between the way that IP and SDI do their division.
Yeah, actually, I think we might not use 420, but in my understanding, according to my understanding, 420 for SDI, we need to insert null data to transport a constant bitrate SDI system.
Yeah, because of the fact that SDI is divided into certain bandwidths, right, which tends to be multiples of 2, there's no mechanism for taking advantage of the difference between 422 and 420. They have to fit into the same size box because there's only one size box. So SDI doesn't. It just transports 422, and yeah, half of the chrominant samples are not used. But I think anyway. I think you would be better to use the same technique for compatibility. It's also an ITUR standard which was published 3 or 4 years ago as well, 2077, and it really worries me when slightly different techniques are used for different mechanisms. It's just a compatibility nightmare. Thank you.
Okay, I see.
Last one.
Hi, Lee Wickham from Imagine Communications. Because you've got multiple streams, when say you're switching from one camera to the other, you have the issue that each of the streams will switch at different times, and you tend to get glitches on your final 8K output. What have you done, or have you looked at that problem of switching and how to control glitching when some streams have switched and the other streams are still in the process of switching?
2110 provides a synchronization method. So we use RTP timestamps to switching.
Right, but you can use the RTP timestamps, but you still have the issue that one stream has switched, the other stream hasn't. So you end up with an image which has one quarter of the image, or one section has the old stream, and another part of the image has the new stream. So you'll end up with a frame or two where you have a composite of some of the old pixels and some of the new, depending on which stream they came from, because the network is still in the process of switching.
So you mean the multiple video processor doesn't synchronize? Sorry, I don't know if this is the answer of your question, but we send switching operation to vision mixer with RTP timestamp. So the switcher output is also synchronized, and the image is not different.
Yeah. Anyways, it's a problem with the switcher input, so you may want to look at that, because that's been an issue when you have these multi-stream things, is making clean glitchless switching has been a problem, so just something to keep an eye on.
Okay.
You can discuss via coffee afterwards.
Sorry.
Thank you, Koyama-san.
Thank you.
Thank you very much. Your papers.
Thank you for watching. If you enjoyed this video, please tap the like button and also subscribe to our channel to receive notifications when we add new content. For more information about us, please visit SMPTE.org. We'll see you next time.